and welcome back to my channel Java with Ali, and I am Ali. So today we are going to look at the binary search and we're going to do a very simple example so you can understand the concept. And I'm going to use my playing cards. Where are they? Here they are. So we have searching, which we did in the previous video. We did linear search, and now we're going to look at binary search. So also as well, please like, share and subscribe if you want me to continue making more. That would be great. Thank you. And I really appreciate the subscribers so far. There are so many. I'm really happy. So here we have our playing cards. So I have because I love making videos, so I just took the hearts from the deck. So because we have our binary search here, we have linear search, as we said, is going to be really inefficient because it takes each individual item, it's not sorted, and it just goes through each and every single one. And then with binary search, it is sorted and then it just goes to the middle element first. So we're going to look at the middle element here first, which is 5, and whatever number I'm looking for, I check whether 5 is going to be less than this. So if it is, then I just get rid of all the rest of these and I look at the rest of these. So I split these off, and then it just searches, and then it goes to the middle again and it searches through there. So it's really efficient that way. So we say that it is 0 written in big O notation, so 0 and then log n, or this would be also known as order log n, and this is your logarithmic runtime. This is where our searching and our hardware go hand in hand, because you can also let a lot of your search tools and things like that run continuously, and it will take up a lot of space in your memory and also slow down everything and processing in the background, etc, etc. I'll come to that in more detail in another video, but for now we're just going to look at the binary search test. So I'm going to go through this line by line. We have 3 imported packages here. We've got our secure random, so we're going to have some random generator here. We have arrays, so we're going to use the collections part as well. Java.util.arrays is part of the collection, so if we wanted to make something to string, or if we wanted to do something like that, then we use the arrays collections. And we have scanner, which means we're going to have some sort of input from the user. So now we have our class name, always starts with a capital, binary search test. Then coming to the most important part, which is our method called binary search, and it returns an int. It is static, so it takes there's one instance of it, and we have and it takes in through our parameters here. We have an int, which is an array called data, our int, our regular int of key, and then we have our declarations here. Int low is equal to 0. High is going to be the data.length minus 1. If I didn't put in minus 1, what would happen? So we know that the length of an array, and when we define the number of elements in the array, and the length are going to be so if we say data.length, or if we just want to access whatever element within the array, how we access it is going to be different. So here we have high, here we have int middle, which is going to be low plus high plus 1 divided by 2. So this is going to get to our middle element, and we're also going to print that out in screen. Now you can print it out with the word mid, which I did, or a star or something like that as well. Minus 1 is our sentinel value, and if you saw the previous video, I didn't refer to it as sentinel, but it is sentinel value. I did post up the little note as well on that video. So we have our do statement here, and we have our system.out.print, which is going to call a method within that. So if I go down to this method then and have a look at it first while it's called, and it takes in our data, which is going to be an array, an integer of low and high, and a string builder temp. So if you're not sure if you're going to use a string builder or a string buffer, I also have a video about that. You could check it out in the other series. But for now, we're just going to plow ahead. So here we have our for loop, which is just our standard for loop. If I is less than low, then keep going. If I is equal to low, then I must be less than or equal to high, and then keep iterating, and so on. And then we use our string.format here as well to print it out. So let's go back to where it was called, up here, and we have our for again. So if our for loop then is I is less than middle, then iterate through it. Now you could print out this as well. So I just decided to put in, but this will print out every single time it goes through it. This will print out as well. I'm going to change this to a star so it's easier to read. We put the value of the middle into access. This is how we access our array elements. So this is our key is going to compare our key, whatever the user puts in, presumably, which we'll come to that part of the code in a second. So whatever the user puts in, whatever we're searching for is usually called key, and we're going to check, we're going to compare here with the key. So if the middle, then if it is equal to, then the middle is the location. Or else if key is less than data, middle, and then we assign the value high is middle is -1. And because we're going through this in the if statements here, it actually is doing exactly what I showed you there with the playing cards. So with the playing cards, you can see that they're like the location is currently in them. So if I write down some notes here, location is the current middle. Then here, I switch between different laptops. Middle, this would be more like, okay, here if I write middle is less than, so we have our else if less is too high even, is too high. And then we have high is now going to be eliminate the higher half. So like I said here with my playing cards, oh, I just dropped some. Let's just take a few, 5, 6, okay, perfect. So we have our, I need to sort them first because that's what binary search does. So if we go 5, 6, 7, 8, 9, what we're doing here is what we're doing in this program, because we gotta go to the middle first, check if this is greater than or less than here. If we want to say, if we're searching for the higher numbers, then we eliminate all of these and then we check these and do the same again. So with that then we have our else here, which is going to check our final check, which is middle element is too low, and eliminate the lower half. Okay, then we have to recalculate the middle, which is what I just said. Recalculate the middle. So this is our recalculation of the middle, where we take our low plus our high plus 1 and divide it by 2. Here we had also low plus high plus 1 and divided by 2. That's how we're going to calculate the middle. So, and then return the location. So we've already gone through the remaining elements. Now we're going to go to the main. So this is actually the starting point of the program, but I read it in sequential order, obviously, just to show you what other parts are called. So here we have our input, which we knew was going to happen because of our import packages, also our random number. And here we use our collections, our int stream as part of ints as well. So we have our rand num, then we use the ints, which is producing a stream where we have 15 numbers from 0 to 40. If I just hover over this, as again, you can see there's an int stream size, origin, and bound, and that's inclusive and exclusive, and then it's going to be sorted and go to array. So if I want to maybe make it to 100, that might be better. And then we use our collections, which is arrays to string, because I said that a while ago, we always use arrays.toString. And if you're unsure about why, check out the previous video, because when you just print out the string, the array directly, it will just print gobbledygook. So you can see that in the previous, a very technical term. Anyway, that's besides the point. I'm just focusing on this right now. So we have, please enter an int value or type -1 to quit. So then we take our input, we assign it to the search int, which is going to be later our key that we're searching for. So if I want to I could name this to key int or something, because that this is what our user enters. Whatever our user enters, then if it's not equal to -1, so if the user has not quit, because we type in -1 here to quit, and we also have it up here as the return location is -1. Okay, if it's -1, then quit. Then we call our binary search, which we went through already. So that's our data, which is what we have here. Hope you're following. And our key here, and we pass it through our binary search to go through it. So we're going to eliminate half the stack of cards, or we're going to search for the middle part, sort it first, search for the middle part, and then eliminate half, depending on whether it's less than the amount that we're searching for, etc. If the location is -1, we press obviously not found. Otherwise, we're going to print where it is found. So this is our key that we print and our location, and then we ask the user again. So if I just press play, this is available on GitHub. You do not have to pause the video to type it out. I would highly suggest, as practice, to type out this code and see, for instance, line 74 and line 75. If you eliminate those two, what happens? If you eliminate things like if location equals -1 on line 67, what happens? And go through the code individually. You can also drop kind of breakpoints in each and go through it like that. If you're using things like IntelliJ, or if you're using other integrated development environments, I'm using Eclipse. If you're using IntelliJ or other ones, then it's good to know kind of your way around as well. So I'm going to say so here is, we're kind of cheating because we already know what the array values are. But if we didn't, then we'd go through it. But just for demonstration purposes, I'm going to say 33, which is here. So if we manually check where it is, so 0, 1, 2, 3, 4, 5, 6, 7. Press enter. I is S in the middle. It's found in position 7 because it's 0-based counting. Like I said before, the element in the index of the array is not equal to the length. So now if we want to search again, and if I say 51, then it will show that it's at position 10. I'm going to eliminate the line here. So because I've just taken out a line, the previous lines that I was referring to is going to jump to one less. So I'm now going to stop and run the code again. And let's say if we manually do this, so 0, 1, 2, 3, 4, 5, 6, 7, 8. Let's say I want to check for 57, okay? But the middle then is going to be right here. So let's say if I want to say 57, so it should show me the middle point. It's a really nice part. So 0, 1, 2, 3, 4, 6, 7, 8. So 9, 10, 11, 12, 13, 14. So if I wanted to, let's say, make this 10 instead and go from range 0 to, so you can see here, like I said with the cards, it breaks off half and then again until it has smaller and smaller and smaller until it gets the actual answer. So here then, let's go again. So we have fewer amount of numbers, and I'm going to say 5. This is kind of fun because we have duplicates for 5, and you can see here, so we have 3, 5, 5, 13, 27, 38, and then I have here, and the middle is going to be at 44, then at 13. Let me check there, the middle is correct with the star, yeah. And it says that it's at position 2, so 0, 1, 2, which is kind of fun to do, but you can research that yourselves. So that is binary search. In the next, we are going to look at selection sort, and we're going to check about being selection sort is simple, but again, it's a little bit inefficient. And yeah, we're going to have a look at that in the next video. So thanks for watching, and if you like the video, please like, share and subscribe and tell your friends. Okay, thanks, bye.